Hello again. Here is the 433 megahertz key fob board that's I posted this on LinkedIn earlier and mentioned I might make a video of it for the antenna matching. This will follow the same procedure as the previous video on antenna matching. You can get all the minute details from that video. This is going to be a little bit more focused on this particular antenna because there's something at the end of the antenna matching that I want to show everyone. So it's going to be the same process. We're going to solder an SMA to here, right at the end of our pi network there for the matching network, Z1, Z2, Z3. We're going to calibrate the machine. We're going to get our complex value. We're going to punch that into a calculator and correlate that to inductor, capacitor values, put them on the board, see how it works out. So let's get started. I'm going to put this on and then we're going to focus on the machine. Okay, I lied. I will go through this again. I soldered the antenna, the SMA to the antenna, but I'll go through the calibration one more time. Let's see, I'm going to go center frequency 433 here. I'm going to use a span of 50 megahertz. Marker set to 433. You have to do that before your calibration because if you don't and you change the frequency after cal, you're going to lose your cal. So you have to set the frequencies up before calibration. So we're going to go to the cal button. I'm going to, let's see here, modify cal kit. No, oh, there we go. Still not completely used to this VNA. Okay, so I'm going to select my cal kit called good, if you remember that from the previous video. Okay, so there's my cal kit. Selected. I'm going to go to calibrate. Once again, we're just doing a one port cal, open short load. Here we go. Get my standards out. And we're going to set this to Smith chart so we can see. All right, so calibrate, one port, open. There we go. Short. And I apologize if the audio is coming out terrible. I use a Nikon D7500 as a camera, and it takes fantastic pictures and videos. I can't seem to get the external microphone to work very well. Load. We're going to say done. Okay. So our standards are now mathematically entered. So we are now going to do the port extension. Remember, my series matching component is open, so I'm just measuring the first section of trace on the board, the connector and the first section of copper. So we're going to hook up our board. You're going to see that the open is now moved down here. Once again, extremely important. So we're going to go to, let's see, I can never, once again, I have a hard time with this adapter removal. There it is. Okay, and we're going to go select port. Oh, sorry, select port 1. Oh, geez, what am I doing again? I can never remember this one. Oh, port extension. There we have. Sorry about that. Port extension. We're going to measure the open. Port extension. There we go. All right. So now our port extension is calibrated out. So we now have a calibrated open. So now I'm going to stop the video. I'll solder short the series component, and we can get a measurement of the antenna itself. Okay. I'm going to throw this portion of the video in here. Here is a closer up view. I don't know if you can really see it that well, of the VNA. We have a complex value of 4.2 minus 170. So we're going to throw that into a calculator and see what we get. Okay, so I plugged the complex values into the analog calculator there online like last time, and it gives me values 67.5 nanohenry, 24.2 picofarad. I'm not sure if the camera's focusing on that. If not, I'll throw an image into the video. And here's what it looks like. And boy, is that terrible. Obviously, there's part tolerances, there's tolerances all over the place. So what it's telling me is you see the small dip there. It tells you you're in the right ballpark. You've got something right here, but it's not much of a dip, which tells me from experience that the capacitor value is too high. There's a trade-off. So I'm gonna lower the capacitor value, but there's a trade-off there. When I do that, the dip will get better, but the frequency will shift to the right. It'll go higher, as you will see. So I'm going to replace this. I'm going to put in, we'll say, a 15 nanohenry, and we'll see what happens there. Okay, there you go. I replaced the 24 picofarad capacitor with a 15 picofarad capacitor, and as expected, the return loss got a lot better, but the frequency shifted to the right. So how do we, what does that tell us? It tells us that we don't have enough electrical length. The frequency is too high, so we need to add electrical length to this antenna. So how do we do that? Well, we take the 68 nanohenry inductor and we bump it up to a 72, which is the next standard value that I have, and that will shift us yet again. So let me do that and we'll go from there. Okay, so now I have a 72 nanohenry inductor, 15 picofarad capacitor, and it comes in at 432, I believe. Minimum, marker search, minimum 432.5 and a minus 34. Minus 35, it's bouncing around, which is pretty good. That's significantly better where it was. So, let me turn the marker, 433 megahertz, that's where it was. I like to tune them a little bit high because this is going into a fob case. It's going to be held in your hand, and whenever you grab something, grab an antenna like this, a key fob or whatever, the frequency is going to swing far to the left. So, but this is the little trick I wanted to show you. This is as close as you're going to get it with standard capacitor values. You can go to a 15, a 16, or 14. It's not going to make much of a difference. What this is telling me right now, since my frequency is a little too low, so again, what is that telling me? It tells me my electrical length is now a little bit too long. So, how do I get the electrical length shorter? Now keep in mind, this is my antenna. This is a little squiggly line antenna that I just came up with. It's just not something, this is not something out of the box. So what do I do to get the electrical length shorter? Well, I'm going to take out my X-Acto knife and I'm going to take a little bit of copper off of the end of the antenna. Usually works out to about 1 mil per megahertz. So let's see how that works. Okay, and booyah, I took off a tiny mount at the end of the antenna, maybe, I don't know, I'll take a picture of a few mils, and I shifted that frequency up to 433.5, which is fine. I really just wanted to show that you could tune the antenna that way. Most people, I shouldn't say most people, some people might not know that it is just a matter of, editing the antenna itself sometimes, rather than sitting there for hours and hours playing with values. So we even picked up some return loss there at minus 38, minus 40. I'll take some pictures of the match, the board, and the edits to it, but that's it. Thank you for watching.